The velocity of a particle is given by v of t is 3 sine t 2 cos t for positive values of t. The particle's initial position vector, r0, is -3, -2, which is this point here. The path of the particle is shown for the first 4 seconds. State what the following definite integrals measure about the motion of the particle. And the first one is the integral from 0 to 1 of v of t. Now, if you integrate velocity, you get displacement. From 0 to 1, that is going to be the displacement change in the first second. Here we have 0 to 2 pi, and this time it's the modulus of the velocity. That's going to be the distance rather than the displacement travelled in the first 2 pi seconds. Now, if we look back at the function, sine t and cos t both have a period of 2 pi. So it's one complete cycle. So, we're asked to determine r of t. Now, in the question, we were given v of t, and that was 3 sine t and 2 cos t. So 3 sine t and 2 cos t. So we need to integrate. If we integrate sine, we get negative cos, so that's going to be -3 cos t. And if we integrate cos, we get sine, so that's going to be 2 sine t. We know the initial position was at -3, -2. So r of 0 was -3, -2. Now when t is 0, -3 cos t is -3, so we don't need to add a constant. But sine of 0 is 0, so we're going to need to put -2 here, so that r of 0 is -3, -2. Now we want to determine the Cartesian equation for the path of the particle. So going from what we just established up here, we have that x is equal to -3 cos t, and that y is 2 sine t take away 2. Rearranging, that gives me that cos t is -x over 3, and that sine t is y plus 2 divided by 2. Now we know that cos squared t plus sine squared t is equal to 1. But here that's going to be x squared over 9 plus y plus 2 squared over 4. And so we have that x squared over 9 plus y plus 2 squared over 4 is equal to 1.